Hello students, welcome you all. Today we are going to discuss theorem 10.6, then 10.7, then we can move to exercise 10.4. So let's read the theorem. Equal chords of a circle or of congruent circles are equidistant from the center or centers. So here it is saying about either one circle or of congruent circles. Okay, similarly center or centers. Okay, so let's first take it for one circle, then we'll discuss about two circle. Okay, that means two congruent circle. So let's start. So here what is given? Given is equal chords of a circle. That means chords are equal. AB equal to CD is given. AB equals CD are equidistant from the center. This is what we have to prove. To prove OM, equidistance means the perpendicular distance. Always remember that distance from a point means it is perpendicular distance always. So we have to prove that OM equal to OM. OM equal to ON. Now we'll move to the construction. Here we have to construct OB or join OB and OD. So join OB and OD. Now we'll move to the proof part. In the proof, we will take these two triangles, triangle OMB and triangle OND. In triangle OMB and triangle OND. Now in between these two triangles, we have OB equal to OD. OB equals OD. Why? Radii of the same circle. Then we can say these angles are 90 degree. Angle OMB is equal to angle OND. Angle OMB is equal to angle OND. Region is 90 degree. Now we have right angle, two right angles. One hypotenuse is equal. Now if one side will be equal, then these two triangles will be congruent. You see, AB was equal to CD. Therefore, half of AB is MB and half of CD is ND. Now MB is equal to ND. MB equals ND. Give region as AB equals CD. Implies that 1 by 2 AB equals 1 by 2 CD, and 1 by 2 AB is who? MB, and 1 by 2 CD is your ND. Look at the figure. 1 by 2 AB is MB, 1 by 2 CD is ND. Implies, you can write, implies now two triangles will be congruent. Triangle OMB is congruent to triangle OND. Region is your RHS. Now as these two triangles are congruent, OM will be equal to ON. So OM equals ON. This is what we needed to prove. OM equal to ON. Now same proof we will try in the next picture. Next figure. Okay. So let's see. Here question remains the same, but there are two circles. That means two congruent circle, and you know that in congruent circle the radius are same. So here given will be same. Then you have construction, all are same. Okay, we have what we have to construct? Construct OB and O dash D. Baki given and to prove are same. So let's take two triangle OMB triangle. In triangle OMB and triangle O dash ND. O dash ND. Now in between these two triangles, you have OB equal to O dash D. OB equal to O dash D. Region is your radii of congruent circles. then these angles are 90 degree, angle OMB equal to angle O dash and D, this angle. Now same as AB was equal to CD, therefore half of AB, that is AB, will be equal to ND, half of CD. MB equal to ND, give the same region that we had given in the earlier part. Okay, implies two triangles will be congruent. Triangle OMB will be congruent to triangle O dash and D. Now as two triangles are now congruent, these two triangles are congruent, their corresponding parts will be equal, hence OM equal to O dash N, implies OM equal to O dash N. So this is what we needed to prove, hence proved, you can write.